All right, we're in section 4.7 of Al Grosch's book, Developmental Math 2. The topic of this video is division of polynomials. We're going to start with monomials, but we're really only going to divide by monomials. Division by higher polynomials is actually a topic for another class. So let's look at the first example. It says simplify 30x to the fourth y cubed divided by 15x squared y7. We've actually done this before. We actually did it earlier in chapter 4 when we talked about exponents. Dividing a monomial by monomial, let's just review. A monomial means one term, so this is all one term. Dividing a monomial by a monomial is simply just reducing. So that's what we're going to do. We're just going to reduce. You can see how the author kind of lays out all the factors down here. I'm going to actually do the same thing so you can just kind of see what's going on here when you reduce two monomials. First, we're going to look at the numerator. We've got 30x to the fourth y cubed. We're going to write 30 as the product of prime numbers. When you do that, of course, you can use the tree on the 30. 3 times 10 is 30, and 2 times 5. So we end up with 2 times 3 times 5, and that's your 30. X to the fourth is just 4 x's, 1, 2, 3, 4, and y cubed is 3 y's, and that's just prime factorization. Same thing in the denominator. 15 is 3 times 5. We know that already. Then we have x squared and y to the 7. 1, 2, 3, 4, 5, 6, 7. Now, you're not going to have to do this all the time because we can use the shortcuts that we already know, but this is just to show you what's actually happening. When you write any kind of a fraction out like this as prime factors, you can reduce any factors that match on the top and the bottom, and that's what we're going to go ahead and do here. We can reduce this 3 over this 3. That just makes 1. This 5 over this 5 also makes 1. These x's reduced. They make 1. And back here, let's reduce off 3 of those y's. So you can see what we're left with here. We're left with a 2 in the numerator and a couple of x's down there, which when we multiply them make x squared. In the denominator, what are we left with? Just some y's here. There are 4 of them, so we're left with y to the fourth. This is just the result of reducing. Now you can do this mentally. You know 30 divided by 15 is 2. When you reduce the x's, you subtract the exponents. 4 minus 2 makes x squared. When you subtract these y's, there are more of them on the bottom, and you're actually subtracting it the opposite direction, and that's why the y's end up on the bottom, because there were 7 to start with. So after reducing, all the leftovers were still on the bottom. That's basic reducing or division of monomials. So we're going to try it on a couple of examples here. I'm going to zoom a little bit. All right, we're going to start with the coefficients. We have 6 over 20, which doesn't reduce to make a whole number, but it can reduce as a fraction. 6 and 20 are both divisible by 2, so you can reduce this down to 3 over 10, and that's how we're going to start. We're going to start with 3 over 10. And then we'll reduce our x's. We have 5 on the top and 5 on the bottom. Well, what does that mean? That means they're all gone. They've all reduced off, so there are no x's left. With the y's, we have 2 on the top, 2 y's, and 1 on the bottom because this is the invisible 1. When they reduce off, you can subtract. You will have 1 y left. It will be here on the top since most of the y's started on the top. With the z's, you have 2 on the top, 10 on the bottom. When you reduce them, there'll be 8 left. You subtract. But they will be on the bottom because there were more on the bottom. So we have z to the 8th. So that's 3y over 10z to the 8th. We're going to do the same thing with this one. We're going to start with the coefficients. So negative 3 over 9 reduces to make negative 1/3. So we're going to write this out. I like to stretch out that fraction bar since my variables are all going to go in that fraction. I have a's, 1 on the top and 6 on the bottom. When I reduce, there will be 5 left. They will be on the bottom since there were more on the bottom to start with. When I look at the b's, I have 5 on the top, 2 on the bottom. Subtract, there will be 3 left. They will be on the top. There's nothing to reduce with this c cubed. There are no other c's, so the c cubed is still there. And what happens to this d0? Remember from an earlier lesson that any number to the 0 power equals 1. So this d is just turning into a 1. We can write that 1 here because we're going to take a few minutes to just simplify this now. In the numerator, the coefficients come to the front and they multiply. Well, this is 1 times 1, or negative 1, still makes negative 1. So we have negative 1 b cubed in the numerator. Actually, we don't even need the 1, do we? It's gone. We can just write negative b cubed over 3a to the 5th c cubed. You can write the 1 if you want it. Most of the time in algebra, we don't write the coefficient of 1. All right, on this page, we're going to step it up just a little bit, and we're going to start multiplying other types of polynomials in the numerator. I'm sorry, this is not multiply, it's divided by a monomial. So we have this trinomial here, 3 terms, divided by a monomial. The easy way to do this is to separate the trinomial into each their own fraction. So the first term becomes the numerator, and the monomial on the bottom becomes the denominator, and they will all 3 terms have the same monomial on the bottom. So this first term, 10x squared over the 2x, minus, coming from here, 8x over 2x, plus 4 over 2x. So maybe we can write it over here so we can see what's happening. 10x squared divided by 2x minus 8x divided by 2x plus 4 divided by 2x. And then we just proceed like we did on the previous page where we just reduce. So 10 divided by 2 is 5, and x squared divided by x gives you 1x left over, which will also be on the top. When we don't write the denominator of the fraction, it's because it all reduced off, didn't it? The denominator is 1. We don't usually write it. So we have a minus sign. 8 divided by 2 is 4. And the x's cancel on this term because they're the same on the top and the bottom. Then we have a plus. And this can be tricky. We have 4 divided by 2 is 2. And that's a whole number 2, so it would be the top of the fraction. But we have left in this fraction that x in the denominator, which has nothing in the numerator to cancel with it. So we need to leave that x in the denominator. It does not become 2 times x. This 4 divided by 2 does become 2, but the x still has to stay in the denominator. It becomes 2 over x. So we end up with 5x minus 4 plus 2x. So we have a couple of examples down here. There are 2 terms in the numerator, so we're going to make 2 fractions. They will both have the same denominator. So they will be 12x to the 4th over 6x cubed, minus sign coming from here, 3x over 6x cubed. And now we're just going to reduce. 12 divided by 6 is 2. X to the 4th over x cubed, subtract, leaves you with x to the 1. It's also on the top, so I don't need the bottom of this fraction. In this fraction, though, 3 divided by 6 does not make 2. 3 divided by 6 is a proper fraction. It's less than 1 because the numerator is smaller than the denominator. So reduce this fraction to 1/2, and we are going to need the numerator and the denominator of this fraction. Look at the x's, x to the 1, x cubed, subtract. You have 2 left over. They will be in the denominator because there were more there to start with. So 2x minus 1 over 2x squared. Number 2, we're going to have 3 terms this time. So 20 x cubed y cubed coming from here over this denominator. 5x squared y cubed minus 7x y to the 5th over 5x squared y cubed plus 35x to the 6th over 5x squared y cubed. So all you're doing is you're taking each of these terms from the trinomial in the numerator and making a new fraction out of it. They all have the same denominator. And now we're going to reduce. So 20 divided by 5 is 4. Sometimes it's easiest to go ahead and make a fraction bar. 20 divided by 5 is 4. That's a whole number 4, so it's on the top. X cubed divided by x squared. Subtract those exponents, you get 1. There were more of them on the top, so we'll have 1x on the top. Y cubed divided by y cubed is canceled. So there's really nothing in the denominator of this fraction. It's basically 1, so we really don't need it. So this is going to be a whole number 4x in this term. All right, we have a minus sign from here. 7 divided by 5, actually, that doesn't reduce. So we're going to end up having to have the numerator and the denominator of this fraction because the 7 and the 5 won't reduce. X over x squared. Subtract, you get 1x on the bottom in the denominator. Y to the 5th over y cubed. Subtract, you have 2 in the numerator. So this becomes 7y over 5x. Plus sign from here. 35 divided by 5 is a whole number 7. So we're going to keep the bottom open. There's a 1 there. X's, subtract 6 minus 2, you get 4. There's more of them on the top, so the x is going to go on the top. Okay, this y cubed has nothing to reduce with, so we're going to need the y cubed on the bottom. So that becomes 7x to the 4th over y cubed, because you don't need this 1 coefficient. And this is your final answer.